Imagine a world of water under the surface of the Earth. So much water that there's nearly 6 times as much water than in the Earth oceans on the surface. For decades, we've had marvelous novels and big Hollywood blockbusters showcasing hidden worlds, exotic landscapes deep within the realms of the planet, no matter how ridiculous they are.
Gentlemen, I give you the center of the Earth.
Well, it turns out the idea of a hidden ocean isn't too far-fetched according to science. According to some brand new research released from Frankfurt, we found evidence to finally put a long-standing hypothesis to bed.
I'm pretty tired. Think I'll go home now.
Located deep within the Earth sits a layer known as the transition zone. This layer separates the Earth's upper mantle and lower mantle and is between 410 and 660 meters deep. In fact, it's so deep that there are around 23,000 bars of pressure, which cause the crystals in the rocks at that depth to actually change their crystal lattice structures. This crystal is known as olivine, which is an olive green mineral and is also called peridot. It constitutes around 70% of the Earth's upper mantle. At the boundary between the upper mantle and the transition zone, at a depth of about 410 kilometers, it is converted into a denser wadsleyite, and then at 520 kilometers, it metamorphoses into an even denser ring woodite. These mineral transformations greatly hinder the movement of rock in the mantle. For example, mantle plumes, rising columns of hot rock from the deep mantle area, sometimes stop directly below the transition zone. The movement of the mass in opposite directions also come to a standstill. So subducting plates from the surface often have difficulty in breaking through the entire transition zone. So there is a whole graveyard of such plates in this zone beneath Europe as an example. However, up until this point, it's not been known what the long-term effects of this sucking material into the transition zone had on the chemical composition and whether large quantities of water existed there. For example, we know that oceanic plate, once it subducts beneath continental plate, it often pulls lots of gases as well as water as it was once under the sea for hundreds of millions of years. And here's where things get interesting, because unlike olivine, ringwoodite can store large quantities of water. In fact, so large that the transition zone would theoretically be able to absorb 6 times the amount of water in our oceans. So that's the theory, but how can we prove that there is actually water down there? For this international study, Frankfurt geoscientists analysed a diamond from Botswana in Africa. It was formed at a depth of 660 kilometers, right at the interface between the transition zone and the lower mantle. In fact, at these depths, that is where we would start to see ring woodite occur. Diamonds from these depths are extremely rare, even among the rarest of diamonds, so we're talking about 1% of all diamonds found. Further analysis of the diamond found ring woodite inclusions within its lattice. And ring woodite naturally has 1.5% of its crystal lattice structure as hydrous oxide ions. And furthermore, the geoscientists were able to actually determine the composition of the stone in which the diamond was found. It was almost exactly the same as that of virtually every fragment of mantle rock found in basalts anywhere in the world. This showed that the diamond definitely came from a normal piece of the Earth's mantle, and it wasn't some anomalous diamond which could have had other sources and means of creation. Now, whilst the novels and the Hollywood stories always depict massive expanses of cave networks and underground creatures, we're obviously not going to see that due to the immense pressures that the transition zone has. But it is really cool and exciting for science to know that we are getting one step closer to understanding the inner workings of our planet. If you like this video, please subscribe and hit that like button. It really helps me out with the algorithm. And if you do use TikTok, follow me on my TikTok page. Socials are in the bio below, and I'll see you in the next video.